I'll be talking through the solution to question 6 from the 2015 exam paper, the unit Mass of Graphics and Virtual Environments. Okay, question 6a asks you to define backface culling and painter's algorithm, or explain them. Backface culling clues in the title. It means you cull any backfacing polygons. So those polygons where the normal vectors are facing away from the viewing position. And these are just simply removed from the scene, and that ensures the viewer does not see the back of enclosed objects. Painter's algorithm, this is where you list the polygons in descending order by the z distance from the origin. Okay, so that ensures that scenes, polygons which are further away are obscured by closer polygons. Okay, part B, with the aid of a diagram, explain how the dot product between the viewing vector v and the surface normal n is used to determine whether a polygon is front or back facing. So here's my diagram. P is the viewing position, and we've got two polygons here. I've got one front facing where the normal vector is sort of facing the region where the viewing position is, and another back facing where the normal vector is facing away. Now the viewing vector from the position P to this polygon is here, V, and the angle between the viewing vector and the normal vector I've labelled as theta. Now for the front-facing polygon, this angle is greater than 90 degrees, or pi over 2. And for the back-facing polygon, this angle is less than pi over 2. Okay, so if we have a look at the definition of a dot product, v dot n is equal to the product of their magnitudes plus the cosine of that angle between them. So for the back-facing polygon, where the angle was less than 90 degrees, the cosine will be positive, because cosine is positive when the angle is less than 90 degrees. For the front-facing polygon, where the angle is greater than 90 degrees, the cosine is going to be negative. So because these magnitudes are always going to be positive, so when v dot n is negative, we have a front-facing polygon. When v dot n is positive, we have a back-facing polygon. Part C, you're given 3 polygons and with their 3 vertices. Okay, so each polygon A, B and C are defined by 3 vertices. Determine which are front or back facing. So the surface normal vectors, okay, these are just calculated with P2 minus P1 cross product with P3 minus P2 for each of those vectors. So this is a cross product calculation. The viewing vector, well, you're told that the viewer is at the origin. So the viewing vector is simply the centre of each of those polygons. So to calculate the centre of a triangle, you simply add up the vertices and divide by 3. Okay, so these are the centres of each of the polygons, and hence they're the viewing vectors. Okay, so then simply calculate the dot product between the normal and the viewing vector, and it's positive for polygon A, so therefore this is back facing, but it's negative for polygons B and C, so these must be front facing. Okay, finally, part D, determine the order that the front-facing polygons in part D, so in other words, polygons B and C, are rendered in Painter's algorithm. Okay, so if we look at the Z coordinate of the centre of the polygon, for B it's 9, and for C it's 14 over 3. So in descending order, you go B, then C.